Good catching up with all of you, Eric Tudor. All right, so here's my proposal for the day. I thought it would be great to we're 12 plus hours into this, and by the way, I'm so grateful for Tudor, your time, and Eric's been it's been a total trip to be learning with you along with Tudor. I had
For sure.
this. Love to kind of go through what my learning objectives were. Maybe share what I've learned. I took some time to write it out, and maybe describe where I want to go from here. And Eric, I would love for you to do the same. Doesn't have to be written, but even just walking through it. Oops.
I've got it. I've got some slides too.
Okay, cool. So okay with you, how about we just kind of both go through our report outs, and Tudor, just jump in wherever you want and help us kind of reflect and learn. Does that work for you? Okay, cool.
Sounds great.
So I'm not sure if I told you, but for me, like this one thing I've been wanting to do for the last year plus, about like a year and a quarter, is write programs with a reasonable UI, with like a minimum degree of effort. And I saw this quote that said, compared to say 20 years ago, writing programs with UIs is much harder. Like before, you had like Visual Basic, you could sort of, you could just make a program with a menu bar and a dialog box, right? And you could have that running, very, very quickly. And now it's like super hard because you have to, often people have to write a JavaScript part and then a backend server part, and it's just like really hard, right? And so that's a bigger thing. But I thought there was the fact that we can go on this adventure together, and I thought that there would be something to learn about what it would take to learn about writing programs with even a reasonable UI. I learned a lot about that as well. Anyway, so that was one. Two is I wanted to learn about a different way to program. Learning Clojure was transformative to me, right? The whole notion of a REPL kind of as a way to program instead of compile, load, run, crash, try again. And Smalltalk has always been held as the paragon of that. So that was certainly one of them. And just to watch Tudor be able to solve a even trivial program that was such a treat. And Eric, I can think the reason why I reached out to you was in one of your podcasts, you said, how do the Smalltalkers do so much with so little? Like 100 pages, 180 pages of code, for those early versions of Smalltalk. And we were talking about was it the Dan Ingalls video? It's still like that, was just amazing. So kind of boiled down to four things. And I guess that stood out to me as like these big aha moments. One is my favorite memory was the Smalltalk debugger. And it was in one of these sessions when I was having trouble with something, and I kept on hitting the cancel button on the debugger, and both of you were screaming, no, don't hit the cancel button. As the muscle memory for me was like, oh, that's just like a dialog box. You got to get it out of the way so you can actually type.
Right.
The notion of being able to make changes, right, and then keep going and kind of fix forward. I feel like I feel like that is new to me. I would just love to learn more about what it really feels like to be able to kind of, oh, something went wrong, keep going, make this change and keep going. I want to go deeper in the stack, not try to unwind the stack and try to figure out what went wrong. So I find that like really exciting and intriguing. The second thing I learned is I got a glimpse of what people mean when they say kind of this dynamic environment. I think often when I heard dynamic environment, I heard dynamic typing, and like to say that characterizes this way of programming is like just kind of the merest sliver scratch on the surface. And especially watching Tudor work, I think I started to gain an appreciation of what it really means when you're programming within a dynamic environment. And so that was like super cool. And Eric, I know you've touched on this, right? Like just what it means to be working in a dynamic runtime environment. So think I kind of heard that intellectually. I felt it viscerally only in these sessions. 3, man, watching Tudor work, it is amazing to see what you can do. Oh, here's your picture of your static website in kind of a impaired mode. Right.
Yeah, are you sharing your screen?
Oh, geez.
I didn't know if you meant to do that.
Am I sharing my screen?
I don't think so.
Oh, I'm so sorry. How's this?
Okay. Yeah, there
Much
you go.
better.
Okay, sorry. Okay, so yeah. Learning objectives. I'm gonna get you guys back up. Sorry about that, guys. Figure out where to park this window here. Yeah, so Smalltalk debugger, dynamic environments. Eric, it's actually something you said, right? It's like you were kind of remarking on Tudor had written that sort of trivial Twitter images renderer. And he was like maybe 10, 15 minutes in. And that kind of reset the bar for me in terms of like, okay, there's a different way to program, right? Where you bring those things much closer in. And I even noticed Jack Rusher coming in the Clojure community talk about moldable development, and he actually talked about kind of that being one of his aspirations in the work that he's doing around Clerk, right? Where he actually brought in sort of input controls into a notebook. And I just thought that was for me, that was a mind expanding thing to see. I think Eric, you said, hey, look, he's already rendering Twitter images, and we're 10, 15 minutes in. And I think for me, the feeling was, oh man, like that changed the way I thought. In fact, even changed the way I programmed, just to be able to say, all right, that's got to be much closer in. The other thing I learned is, man, every UI is so freaking idiosyncratic, right? I mean, like I remember in Microsoft Visual C++, Microsoft Foundations Toolkit, right? Like there are so many idiosyncratic things. Like it's just the way it is. And I thought the same thing about JavaScript browsers, and that was my feeling when Tudor, you were showing Eric sort of the unique idiosyncratic parts about the block.
The layout and stuff.
Yeah, right. It's like, it's so complex, right? I mean, it's just so complicated. It's just full of idiosyncrasies. And I think that's just a necessary part of the domain. In fact, I was reminded when Dr. Gail Murphy, she said, I asked her kind of, we were talking about like how is it that we're just sort of discussing how, isn't it interesting where kind of the world is settled in on Linux or Log4j, logging frameworks or whatever, but man, we keep finding new UI frameworks, and it's just because kind of the needs are so idiosyncratic at the top that it's very difficult to, at this point, say, oh yeah, we understand the problem space so well that it's not like, what is the BLAS library, basic linear algebra system, where it's like, yep, we know the mathematical operations. Here's the one library you can use. UIs, I think, are the opposite of that. And then the other point was like, okay, I think Tudor, it's taken me a while, but I believe you. Mobile development is an important concept, and I got to tell you, it pales, even the pale shadow that we can approximate within the Clojure ecosystem. I appreciate that, and I think one notion is that how do you bring that, not visualization, but I mean that part of it much closer in. I think now that I've felt it, I think it's very difficult to convince myself like I can work on a problem without it. And so, by the way, I was so excited by the progress that we made inside of GT that I was like, okay, I've got to finish this. But I didn't want to. I felt like I was getting mired in the smack parser, and like I couldn't quite test. I kept on running into exceptions in the smack parser, and I couldn't call it outside of the visitor pattern. But I knew I was close, so I actually redid it in Clojure. I think like 2 weeks ago, and I actually got this beautiful visualization working. So I did the same thing, right? Just translated Markdown into some sort of representation. Wrote a recursive descent parser using the same algorithm that we built together, and then shoved it into Vega in a radial tree diagram and used Clerk. And it was freaking awesome, right? I mean, it was not as, it was definitely outside of my program, but it was, I think I built the program in a way that was very different than I would have done it before. And by the way, programming in Vega, like Vega trees are nuts. It's like you're programming in JSON with none of the benefits of imperative programming. It's like really freaking hard. It's like you're just generating all these random JSON nodes, right? That anyway, so I want to publish a bare bones example of how to do this, because that took me about 3 hours, and that was like tough sledding. Anyway, but I felt like I got pretty close, and this is like a useful tool for me to understand, like, oh, this is the outline of the book I'm working on with Dr. Stephen Spear, and like, oh, this is an outline. This is actually doesn't have any organization at all. I mean, this is actually a pretty useful tool for me. So I want to build the animation that kind of shows across all the Git check-ins, render this. So I'm like kind of excited by where that goes. So where I want to go from here, I want to know how far. I want to learn more about debugger-driven development. The notion of how do you program in a way where you just run it, take the exception, make code changes, and keep going. And I know that there's some libraries out there in Clojure that kind of embrace the Lisp error condition things, but I'm not sure if any of them actually involve triggering a debugger. I want to put a little call out for help on that, because kind of in contrast to the way that we got to program inside of GT, the notion of like stopping your program, reading a stack trace, and rerunning just seems really kind of unsatisfactory to me. There's got to be a better way. And I got to tell you, of all the things, the only thing that rises to that level, and probably this is even higher, is Eric. I loved your original kind of inspiration, which was how did the Smalltalkers build Smalltalk with so little? And I had suggested in the conversation that you and I had before that, I think for this, right, I think we got to go back to Morphic world to basically kind of live in that. And I think that's where the Dan Ingalls stuff, some of those answers can be found. So I guess the other observation is another example of how people in Smalltalk do so much with so little. GT, Glamorous Toolkit, an example of, I was telling Eric, the fact that you wrote the equivalent of like a big chunk of Vega and GraphViz inside of Smalltalk is like freaking amazing. I mean, it's just, it just shows how much leverage you're getting out of the Smalltalk ecosystem. So I would put GT as an example of like another marvel that, this way of programming is enabled. Anyway, so that's kind of my readout. So, sorry for maybe barreling forward without eliciting comments or whatever. Any comments, reactions, questions?
I have a few, but maybe Eric wants to go first.
I don't know if I have anything that I haven't put in mind, so I'll let you go, Tudor.
So I want to start with that. I think first you said it's we're about 12 hours in terms of effort, right? And we typically tell people it takes about 2 to 5 days of work to have a feeling. So basically to learn how to learn and have a feeling of what's around. So that's our that's the typical suggestion that we have without anybody knowing anything about, for example, Smalltalk, or sometimes not even, they just know some object-oriented programming or maybe some programming. What I found quite interesting is that so there are things that I take for granted because I lived in this world, like, oh, here's a debugger, let's rewind, or sometimes like there's in Pharo, there's a beautiful little framework. It's not little, but it's really, really smart, and which is called Reflectivity, built by Marcus Denker primarily. And it has this beautiful thing, like it can do lots of little things. They can take an abstract syntax tree and you can annotate it. And some of the annotations can even walk back and do things. So you can interpret those while you run. So you can enrich your AST with new behavior that is being dynamically taken into account by the machine. It's really, really exciting. And like when we are, people ask us, why did you pick Smalltalk? I mean, it's this thing, and you just have an executable, right? You download into it, and it's cumbersome, right? It's not on the web. I don't just click one time and I get it. And why did you pick Smalltalk to build Glamorous Toolkit so that we can show what multiple development is? And the thing is, what we're telling people is that we would have probably not been able to conceive of multiple development in another environment. That's the problem, right? And that's the and it's not that multiple development is tied to Smalltalk, but from a research perspective, from a finding out what that thing is, I don't think we would have been able to do it, and not with the effort that we've done. And so this gets us to a couple of the other points that you mentioned. So one of the things you mentioned is that, when you're talking about the UI, right? That UI is idiosyncratic, right? That means I always have to look this word up, right? But I kind of now know what it means, right? That is, everything is different or looks different. Like you'll go from different frameworks will represent different things in different ways. So, and then if you go back to the, like to the original Smalltalk and how did they do it in such a small amount of code, which is indeed an amazing, it's crazy. But the reason they could do it is that different things don't have to be different. If you look at them, right? So they didn't have libraries and they didn't have even a screen, right? They had to invent a screen so that they can put the program in. Just like it's so much more, right, than just those 180 characters. It's just so at the end, right? We got into this idea that for every little thing we need a new other thing, and there's so much missed opportunity, right? You were mentioning about the enormous amount of engineering, I think, during our conversation prior to Eric, right? Prior to recording this, you were mentioning about this enormous amount of engineering put into JavaScript space, right? And this is true, right? And it's mind-boggling what happens there.
And heartbreaking.
Yeah, exactly. It's just brute force. Yeah.
And that's the thing, right? So when you're saying so problems should have been solved.
Yes.
Like we should have had classes of problems that are no longer issues.
Yes.
And we have tons of solutions, right? We have tons of little things for little problems, but we don't have breakthrough in that space, or very
Nothing
little.
New. It's just
right. And and by breakthrough,
brute force
right?
Solutions.
Exactly. So this 180 characters or 180 pages or whatever it was originally, it allowed children to start thinking differently.
Right.
Now that's a monumental thing, right? You just take this inanimate object and all of a sudden people think differently with it. It's like nuts. That's what, like that here we're talking about something you move a big thing with very, very tiny effort. Because you understand that space. So and that's the, like one of the, for the longest time, the Glamorous Toolkit was really slow. And the reason why it was slow is because we had this strange idea of building a whole graphical stack by ourselves. And the reason we built the whole graphical stacks by ourselves was because we wanted to create interactions that was just not possible. And they're still not possible outside of Glamorous Toolkit. So just this little triangle, right? And you're writing something and you have a triangle and you expand it and now you see something while you work. That was the primary motivator
Yeah.
for building the graphical stack. Just that. And then we said, so, you know, but, and then very often when people say, well, you know, why would you do it? Especially like me. I mean, we fund ourselves. We don't have unlimited funds. We're even a company. And so why would you go through this strange thing? I mean, there are so few graphical stacks out there. And if you look who's building them, they are not little tiny shops.
Sure. Google.
Right.
Right.
So you have a few, right? You have a few. And so, and then we said, well, so the reason we would do the whole our motivator is that when you look at how people think today in terms of software, it's clearly wrong, because it's just, you have this, like, it's exactly what you're noticing. People put a lot of effort and just nothing moves really. Nothing really moves. And sometimes it goes backwards. You know, when you have a legacy system, then you cannot move and it starts doing the wrong things. So when you observe those effects, right, we have to change that. How do you change that? Well, we have to completely rethink everything, because people are thinking in the wrong way. So we're back into this world where the goal isn't to solve a problem, but to help people think completely differently. And so that's the space where we are thinking of ourselves in being. And so when you look at this graphical stack, the very fact that we said, well, it has to be simple. Well, not simple, but it has to describe everything. So when I see something on the screen, it has to be there. There's no corner, there's no edge, there's no edge case, right? It's not oh, now I have a visualization, so I should put in there some SVG. That's not a solution, that's a patch. Right. So solving that problem, which wasn't solved really before, and having an editor where you can, which is reasonably scalable, and super flexible, that you can just inject anything you want in it. That was the reason why we built that. And it was two things we learned. So first, when we started, we were not specialists in building graphical stacks. But it turns out that you can become a specialist in building graphical stack. But the greatest thing was, okay, how do we do that? How do we take some super complicated problem that you are not familiar with? And you now need to, it's not just something that you're just taking some script and you're trying to implement, but we have to create something new. We have to create a new design. How do you go and discover that new design by ourselves? And so this is now, it gets to the last point that I wanted to touch on, this idea of multiple development. So the building of everything in Glamorous Toolkit followed multiple development from the start. And the kinds of things, like, for example, when you were mentioning Twitter, the Twitter case, right? This is where we see, right? And you started to feel how it is when I bring some foreign domain that I usually only see in the UI, right? And now I viscerally, I can see it in the inspector, which means that now the feedback loop, right? It's like we're talking about an order of magnitude better feedback loop. You know, like what happens when this and this is even a kind of a shallow feedback loop, because we just looked at the first one. We didn't see what happens when you're doing this and you have 1,000 such extensions and you bring 1,000 little things in your environment. What kind of things emerge out of that once you have that? We didn't yet see it. And so the work, you know, to build this reasonably ambitious system was to say, well, can we do it now following multiple development? And so there is a way to look at Glamorous and say, okay, what can I do with it? Which is fine, yeah. So, but what excites me the most is the fact that, because I know how we built it, and we would have not been able to do it if we would have not for, first of all, of the first environment, because we would have not thought of it. And by the way, like there was someone from the self community where Morphic, right, was first created, came around, and like, so, you know, that idea, right, when you have just one thing and you make everything out of it, is really powerful. So we didn't invent that one, but the question is, how far do you get it, kind of thing. So with this, with multiple development, and here is where the crux of it is, right? Because it's so, right now, because we're packaging multiple development, it's inside Glamorous Toolkit. By the time you get to it, there's so many things that we took for granted when we were thinking of them for the longest time. So that it's kind of hard to say, well, look, there's this other major thing that is maybe around the corner. Let's evaluate that one. But by the time people evaluate that one, they already are, because everybody else is in such an arcane place that, like, it's hard to say, well, look at this new way of thinking about the world, right? So, and then you mentioned the work on Clark. And I think this excites me to, like, this is the most exciting thing, I think that is happening today, because they are building this without our input. And that's so interesting, and it's so exciting. It's super exciting to see, because if this thing has, if this is to really go and, you know, change people's minds, then others have to live it, and package it in a way that touches other people.
And by the way, what an articulate spokesperson, Jack Rusher. By the way, Tudor, I have a thing I want to add to the where we go from here. You made the phenomenal suggestion of, like, instead of watching you solve a simple problem like the Twitter image render, right? It's like, how about watching you solve a complex problem? You had suggested that. I'd love to take you up on that offer, right?
That would be awesome. Yeah.
Okay, cool.
Yeah.
If there's an objection there, can we go to you?
Yeah. Let me share my screen because I made some slides just to.
Awesome. And by the way, Eric, Tudor, when I say idiosyncratic, that's not a judgment. I'm just saying that's just inherent complexity. Like any UI is like full of necessary idiosyncratic things. Yeah.
But
okay.
But still.
Y'all can see this?
Yes.
Right. So these were my learning objectives. I had this question. I've had it for years, ever since I read the early history of Smalltalk. I've worked in Java programs that had thousands of classes, and they still didn't work. And who knows how many pages of code that would be. And the idea that basically the whole operating system, it's got the networking stack, it's got the virtual memory system, it's got the screen, writing to the screen, reading from the disk, all that stuff in 50 classes and 100 pages of code. And I have looked at some of the code to like try to understand what's going on. And I think, Tudor, you're spot on that a lot of it is they're just reusing. They're reusing a ton of the classes for different purposes. They've made very small components that are very reusable. And I also believe that there are a lot, there's a learning objectives. I don't want to go into that, but I wanted to get a sense of that. One thing I didn't realize until sort of halfway into the process one of my learning objectives was I've always seen Smalltalk demonstrated with simulations, and they're usually described like, oh, I made a couple classes and now I got this huge simulation, and it's interactive and you can watch it run. It might be the ants one, it might be that one. I think Dan Ingalls demonstrated this with the assembly line and how so many parts were moving back through for rework, and the conclusion, the obvious conclusion is, oh, we need more people doing work, right? But the not so obvious one is we need to train the people we have because they're making sub quality, low quality products. They have to be reworked anyway. So I've always wanted to be able to do that. And I've dabbled a little in trying to make a simulation, but I always get sidetracked in the complexity of whatever system I'm developing it in. So if it's on the web, it's like, oh, now I gotta install drag, on drag, on drop. And I'm reading docs about how to get this stuff working. And I stopped working on the simulation. So that was a thing that I really wanted to be able to do. Okay. So before I switch the slide, two things. Any questions so far? These were my main two. Okay. All right. That's the first thing. The second thing is, I hope this doesn't come off as too negative, but it probably will. So I just apologize ahead of time. Here we go. All right. What I've learned. So after all this time, I'm so comfortable with the syntax and semantics of the language. I feel like I can write code. And I was surprised by how much the UI is used to write code. Meaning, if I'm in Clojure or even Java, I open a text file, I have to type everything myself, right? Whereas in G Toolkit, it's like, oh, add a method. You click the plus, and then you got to type in the name, and then it, there's like a lot of GUI things that you have to learn. You can't just type the method, whatever, public void, and you got a new method. That was surprising. I also developed a huge appreciation for the development tools I'm used to. I tend not to reach out for new tools. I've been on Emacs for a long time with a really basic configuration. And I know you said that it was surprising how many bugs I was finding in the GUI. I got very frustrated by those.
Yeah, sure.
And so I that really made me feel like, wow, Emacs, I rarely hit a bug in Emacs that would erase 20 minutes of work. And so I don't know if that's a positive or a negative thing. I know that writing a whole interactive development environment is a huge amount of work. But that's something I learned. I also felt a little confined within Smalltalk, just a little bit. I felt like, where are my files? Where can I grep something? Can I see a diff? And maybe it's in there. Maybe it's in there, but I didn't know how to do it. So there's a bunch of things that I would reach for that I couldn't reach for. And so there's a learning curve. I want to discuss this one. I felt like by the end that OO is not inherently better at UI. I guess I had that in the back of my mind. I know a lot of people who believe that you need OO to do UIs, and I guess this confirmed to me that it's not. That the UI framework still has this huge learning curve. It brought me back to my days of having to struggle with HTML and CSS, and how do you center a div and all those problems that took years for me to learn. I was like, I have to relearn all this stuff, but in this new framework. And so that kind of got me to the next point, which is that, so sometimes people will, so beginners face this problem when they're learning Clojure. That's what I'm most familiar with helping beginners learn, which is that a lot of times they're just trying it out. They're not committed to learning all the details that I've committed to. And so sometimes people are like, oh, you just have to learn this and this and this, and then you're ready. And it's like, yeah, but they don't want to learn all those things yet because they don't know if they want to spend all that time. They just want to, learn Mary Had a Little Lamb on the piano and see if they like it. They don't want to have to learn to read music and do scales and all that stuff. And so I kind of wonder whether for me and the amount of time I want to spend, whether the commitment is too much. Like, I know how I can see from like Tudor's mastery of this, how much it will take to get there. And I just wonder, like, splitting myself, whether I want to go down that road. And then when you were talking, I added this last one. We would have these video calls, and we would trade off. I would be coding and Tudor would be watching me, and then you would be coding and Tudor was watching you. And for a lot of times I would be so intrigued by my problem, working on my code, that I wouldn't pay attention to what was happening with you. And so I feel like you had experiences that I missed in terms of watching Tudor, get the, graph the tree out and stuff like that. So I wonder if I need to go back and watch those videos. Okay, anything more before I move on, or should I finish? Yeah,
maybe just two reactions. I think I mean, just to reflect on that last one. Actually, no. Let's do that fourth one. I think this is what I meant that by every UI is hard. It's like it's so deep and so. I mean, I just use the word idiosyncratic. Just like man, like to learn anything new. Like it's like a tough sledding. So it's very, very deep because it has to be. And I think that's just the way it is, and that's why I guess maybe touches on your second point, which is why I tuned out a little bit, because like as you were kind of going through the idiosyncrasies of the block configuration flags for like snake wrap whatever, it's like I'll file that away from when I need it, but that's not where I'm gonna invest. But there are other parts where I'm like, holy cow, I was riveted. So I suspect there might be some parts like do you really want to know about the smack parser? Like probably not, but there's some parts might be of more interest. So I think I don't think you didn't pay enough attention. That
okay.
I think it was really great that you can sort of. It was great for you to watch us make this amazing progress. Go, holy cow! You got all these things different laid out. It was really amazing to see. Kind of fast forward. How much progress you made in an hour, let alone kind of over the holidays.
Yeah. Okay. Yeah. Cool. The other thing is you're talking about learning to learn. I don't know. Maybe I feel like I haven't hit that snowball point yet where I'm learning to learn. And so I'm learning faster and faster and faster.
Yes.
It still feels like I turn a corner and there's like a whole new thing to learn here. I don't know where to start and I'm stuck again. And
maybe just to react to that, maybe if I can sort of espouse my sensibilities. There's certain things that I don't want to learn. I don't want to invest a whole bunch of brain space for another idiosyncratic UI thing. I mean, unless if the payoff is enormously high, right? So
Right.
it's just the slope is too high, right? And the likely payoff is too small. So like there's some certain things I'm kind of skirting around. So which is the reason why I kind of specifically chose, all right, what's an alternative to exception driven development? Okay, that will be if that I can bring to the way I work, that would be super high payoff.
Yeah.
Uh,
Yeah. That's interesting because
for example, like, do I want to learn Flutter? Like, no,
right. No, I don't want a new thing. Yeah.
Uh,
It reminds me of when Erlang was first getting like its newfound fame and excitement. There was a lot of talk of like, oh, it never crashes, and you just code the happy path. And I just kept thinking, well, like, what is different from what I do today? Because my thing doesn't crash; it just throws an exception. The JVM is still up, and I code the happy path and just catch the exception. And it almost seemed like 90% of the lessons from Erlang, maybe the last 10% is the most important, but 90% of that was solved, and he was comparing it to C from the 80s.
Yeah.
And so I wonder. I was always looking for like, what do I bring back? What can I bring back? And I think that might be what I can do with Smalltalk without having to go deep, commit myself to learning it and mastering it. That there's going to be some good stuff in there about like what you were saying, like what to expect, like how fast can you visualize the thing, and yeah.
Right. And by the way, if I can just rephrase and clarify, why would I not want to invest Flutter? Because like it's too close to like what I know already. With no, it's like the payoff would have to be enormous for me to like go down this very deep chasm, which is why I kind of tuned out when it's like when you were doing the block thing, I was doing the smack parser thing. Right? Certain domains I'm totally would learn. That's like it was worth learning. Immutable databases and MongoDB, right? It's like, okay, that's allow me to solve problems. So I guess I'm willing. Yeah. I want to spend budget more freely there, but there are certain domains like UI. It's like, oh man, very judiciously. It's like, sorry, just to.
Yeah.
So I'd like to say a few things.
Yeah, sure.
So first of all, this is super cool because you were saying like this is negative, and I understand how it can look like this, but that's exciting. And here's why it's exciting. It's exciting because you were at the end of it, right? You're saying that you don't yet feel that you know how to learn yet,
right?
And that's the thing. So the inflection point in any time we've coached anybody to do anything is that that learning how to learn is an attainable goal, which doesn't seem to be the case in other places. So because the way you learn how to learn in other places is, I have a question, I go to Stack Overflow. That's right. Not learning how to learn. That's just getting an answer for your question.
Right.
And specifically, the learning how to learn is learning how to ask the questions, not necessarily how to get the answers. And we didn't touch on it that well yet, indeed. But the biggest thing, the most difficult thing to get is to reach the point where people can start evaluating, but is this a real thing? And what would that mean? Right. So the fact that you feel that you're not yet there, this is the inflection point. If you go a little bit further and just invest, what would it mean? Because like the exercise, right? The exercises you do, those are important. So if the exercises are only focused on how do I get something that I've done somewhere else and I do it here, that's okay. It's interesting. It's an interesting exercise, but it will not necessarily get you to learn something that you haven't expected to learn.
Right.
And so now, but what if now that you know that this is something that is interesting, and you visually feel, oh, I'm not quite there, I don't quite see it yet. What if you pick exercises that are specifically targeted to, or more targeted, or more, prone to enable to there's literally there's a, it's right there. You've played with most of it, but
Okay.
it didn't. There's no, like, there's a switch somewhere. It's not yet on, and that's it. It takes a bit of time to get there, but from my perspective, this is an exciting moment.
Okay.
Although it might feel negative.
Yeah.
The other thing to keep in mind here is, right, you were talking about the bugs. So imagine we were saying, oh, we have this beautiful car, but the facade of it was kind of made out of cardboard, and stitched together with some some wires there, and it was moving, right? We could drive with it, but you had to be careful that if you wouldn't be leaning too heavy on it, and it will crash. So it's still surprising to me that you two wanted to already spend so much time putting up with those things, because like doing adding a method and then not having the coder properly show you that you have added that method, and then showing you some other method. This is like oh my god, like this should, right, this should never be a thing, right? So it's no longer a thing.
Right.
So while we were working with you, right, for us it was like, this is a treasure trove. This kind of these types of interactions are super interesting, because we get to see what, for us, it's not hard to see, because we knew that those parts were not finished. We just didn't prioritize them, because our goal was to say, well, how do I go from here to somewhere, right? So I put together enough of a vehicle for us to get there. And then we say, oh, look, I could go from here to there. And then people want to come into the vehicle and say, oh, wait, because the vehicle doesn't have a floor. So you're just going to go right through to it, right? So if you know how to stick to it, then you can go there. But
right.
So GT, up to about half a year ago, it was right that one. It was just our vehicle to go to and see how far can we go.
Yeah.
But we knew what to do with it, and then of course, then it worked for us. So it was a validation. It was basically, you can think of it like a research vehicle. But one of the things that happened during the last half a year was that we started to consolidate things. So for example, if you now simple things like just setting up a Git and working with a Git repositories, and
right.
so now there is a little 10-minute tutorial to show you, oh, this is how you do it. You start from an empty GitHub tutorial,
right.
GitHub, and then now you have a whole experience inside GT. It's not finished, but it's good enough already, which gets you from 0 to 1
right.
in within minutes, basically. So
okay,
totally
cool.
different. It didn't exist before.
I'm glad it's helpful, and
very helpful.
Yeah.
You don't, like, it's really helpful from our perspective. Right. So now there's one thing, about this OOP and UI, right? Now, I don't believe UIs are hard, or they have to be hard. It's just that the way we think of them is hard, makes them hard. But you need to have a solid foundation to be able to play with something on top. And I think this is important. And I'm not saying that this isn't an easy problem. I'm just not saying, I'm saying whatever people think about UIs today, it's so driven by the tools that they're experienced those UI through.
Yeah.
And I mean, if you just go into the morphic thing, it made everything so much easier just because we could go and inspect it. And this was at the time you could inspect a little morph. This was at the time when seeing a tree of your thing, I remember once we were playing with Eclipse RCP, not we, but like in some legacy system. And I was like, look at them, and they were basically trying to tell me, oh, somewhere in the parents of this widget this component that I'm looking at here, they are defining something. And I was like, so where is the tree? And they were showing me, oh, they have this extra tool that they were actually paying money for.
Yeah.
You just showed them the tree.
Right.
And I was like, what is going on here?
Right,
I mean,
right,
somebody
right,
built
right.
a framework and they didn't give you even the most basic tool. This is, I mean, that doesn't make any sense.
Yeah.
And
It was
so
compiled
complex.
away.
It's so complex. It
Right.
creates like cottage industries to help you deal with the complexity.
But the problem is that this is a basic tool. This is not a complicated problem, right? And the problem is that we haven't seen the necessary, it wasn't the job of the framework to give you the tool.
Sure.
And that's like the wrong thing. So force forward, a couple of decades. And now we have, right? You have the web browser, and in the web browser, you can see your tree, which was there from the very beginning because you're actually just writing in an abstract syntax tree, which is interesting. So, anyway, so yeah. And then you have these like things for CSS, the width and but how many, where do they live? Where do these things live? They are hard coded specifically somewhere, right? Some bespoke tools completely created in a completely different place than any other tree that you'll ever see. And that doesn't make any sense.
Right.
So if you look into and this is why I'm saying, when you look into the way we debug a blog UI, which indeed is not necessarily a simplistic problem, a simple problem, it can be complicated, indeed. But the way we debug that one is absolutely not any different from debugging any other tree-related problem. For example, how do I debug my abstract text tree, which also happens to be a tree? And so this is where it gets us to the learning how to learn.
Right.
So because everything in an environment like in Glamorous Toolkit, we spend so much time trying to, or well, I don't know if we managed. So I'm just very convinced that this is absolutely attainable. So by the way, like we always say, Glamorous Toolkit is not the end of the conversation. It's merely the beginning of the conversation of how do you make something that looks really, really complicated, has lots and lots of details. How do you make it explainable for another human brain? Or how do you make another human brain be able to explain it for whatever the system is? And the way to do it, and this goes back also to your the thing that like, how did Smalltalk do it with such a small amount of code? And it's actually interesting. There's another interesting project also that by Link, which is called Steps, which tried to build the whole PC personal computer, not PC, the one that you have the whole personal computing thing in 10,000 lines of code. And they kind of managed it, but it's just not. It wasn't finished and it's not packaged definitely. But it was it's an interesting exercise, right? If you look into this, but how do you do it? The way you do it is by finding operators, right? Reusability doesn't happen at the level, oh, I need this functionality, I'm going to use it. The reusability happens at the level of operators, meaning that if you want to reuse something, build a language,
right?
Not just a library. And this is what gives you leverage many times over. So this would be for me, this learning how to learn, that's where it gets to. So multiple development is a way of thinking of decomposing problems in a way that basically that scales, because every problem you solve will train you to solve the next problem, even if the next problem is from somewhere else, exactly because in our mind, it is applicable to every problem.
Okay. Maybe I need, if I'm on the precipice, I should probably keep going. Well,
I think
I'll just continue with my slides because I feel like we could talk about Smalltalk for like, how Smalltalk came to be for a while. I have a lot of ideas there. So where do I want to go from here? Jean and I talked about going to the Morphic worlds, the Morphic UI. I guess for me, the idea with that was that, we talked about one of my learning objectives was to build those simulations. And I don't know, I kind of feel like there's a lot of what do I want to call it? Not reuse, but maybe that's what it is, reuse, that you get for free when your objects are all drawn on the screen and you can already manipulate them. Like the manipulation is already defined, and you can drag them around, and then you just have to say what happens when they collide or when they, stuff like that. That's but I put question marks. I'm not sure. Watch you code more. I feel like I'm maybe missing some of the inspiration that the possibilities that, like, seeing what you could do would open up. But really, I'm not sure. That's
And I think
that's the end.
I was the one, Eric and I talked about this, and I was like, I think, if the goal was like, all right, what was the magic that allowed the Dan Ingalls thing, things to happen, right? I feel like some of those answers maybe live on the Morphic side, but maybe to get there, use some of the amazing tools that you've built. I don't know. I just felt like some of I actually went back to the original questions. Like, well, it seems like by living in GT, we're living in this other place where some of those properties aren't as evident. And maybe maybe there's a way to get the best of all worlds.
Well, so it's interesting because what Tudor was saying about being able to, like, only being able to develop this, to find this in this space. Smalltalk was the only tool that would allow it, right? So, like, why not build it in JavaScript or in the browser or whatever? Like, maybe you could backport it to JavaScript. Now that you know exactly what it's supposed to do, you could just brute force write it in JavaScript, but you would never have developed it in the first place if you started with JavaScript.
Inside of Visual Studio Code extension, right? It's like, that's
yeah,
constrained.
Right, yeah. Well, it's not only constrained, it's maybe too high on the stack.
Yeah,
and Alan Cade talks about how they developed object-oriented programming and the GUI and like desktop publishing and like all these things, fonts, they developed all these things. And he's like, we had to do all of them. Yeah, we had to, because we were publishing papers. So we used our tool to make a desktop publishing system. And that informed how our tool worked and like what language features we needed and what kind of GUI we wanted. And he also talks about they would, like, I don't know, go to a beer garden and drink beer and then come home in the afternoon and do they would talk, they would like have all these ideas like, oh, what if we had a button that did this? And, what if we made a picture that you could click on? And then they go back to the office and they would try them out. And he says that, if you average it out, it's probably about 15 experiments per day, UI experiments. And that's how it got to be. It was like, let's try this, let's try that. So half of them aren't good, right? You try it and it wasn't fun to use or whatever. But you had to try it and explore and find it. It was there, and you had to develop the tools to make it easy to explore. Mm-hmm. So that kind of helped that snowball effect. And yeah, I don't know. That's why I feel like maybe I need to watch you code to get a better idea of where it could go. Um, because right now I haven't done much, but every time I load it up, I'm like, I don't know what to do now. I've got circles on the screen, and um, I don't know how to make this,
Yep.
An actual planetary system with a sun and a planet. Like I don't know where to go from here. And yeah. So I think that's what I want. So to watch you some more, get some more ideas.
So what about Morphic?
Hmm.
I do think that Morphic was great. There's nothing in Morphic that you wouldn't have in Block. So in the graphical stack of GT,
Yeah.
there are many things in Block that you do not find in Morphic. So there's nothing. There's nothing special. No, there is lots of things that are special, but about Morphic. And Morphic, by the way, Morphic was not the first thing that they built. When they were doing those things with images and their
Right.
text editors and so on, this was like 20 years before Morphic.
Yeah.
So
Mhm.
which is another thing. So but what we so you have always have to distinguish between implementing something and finding, like when you build a language of operators, you say, wow, can I just put and play with them in some new scenario and
Yeah.
see how it would feel there. And I can start to, I believe I can empathize with that. um, and then you're going to do these lots and lots of experiments, right? So but the after you're doing that, after you found those initial after you find those initial operators, there's still an issue of how do you add the next level of operators and the next level of operators. And then if you're not paying enough attention, then it's the not all operators that you're going to add are going to be as elegant as the first ones you found. And so, like, for example, if you talk about Morphic, there's the idea, the original idea of it, and then there is the implementation. And it's not the original idea is much more elegant than the implementation that you would find today, basically.
Got it.
And then, for example, one of the things, some things that we're struggling with, not struggling, but like where we are playing with at the level of Block is how do you inject asynchronous behavior into the UI and have it nicely work. So for this purpose, we built the whole futures and promises framework, which is basically kind of equivalent to those that you would find in other languages, but then have it nicely integrated into into the UI. And how do we do that? So there are interesting problems that were not addressed because they were completely out of scope at the time in the original thing. So I don't believe that, I mean, other than if somebody has interest in looking back into history, then Morphic could be interesting.
Yeah. I felt, and this might be my ignorance, I felt like maybe this was because Morphic is more primitive, that it would be an easier path and like easier sledding to kind of get to where Eric wants to go, right? And that going the block route would actually you're having to take on a little more knowledge of the idiosyncrasies. So that was if you're saying that it's as expressive with less rough edges, that seems to be what you're saying.
Who's as expressive?
You
Morphic.
Block, yeah.
No, Block GT, right?
No, it's more expressive.
Right. But the surface area what needs to be learned is smaller.
It's not smaller.
More straightforward.
You can, so block is going to be more expressive than Morphic, just like that.
Okay, so that's one axis, and then
And right, and
but
then
if
you
it's 10
have,
times more
is it,
stuff
is
to
it
learn.
conciseness, right? So you, like typically, right, you talk about a language, usually you have like expressivity and then conciseness. So on this side, we're talking about, can you express many more things or less things with one versus the other one? And then the other one is, how many lines of code do you need to write to do something? You're probably going to write less code with block than in Morphic.
Okay.
So
well, then let's keep going.
And you're going to have more. There are going to be more tools. Because it's exercise in the same place.
Got it. Well, let's keep going then.
Can I propose? I can get busy for the next couple of weeks, but let's put something on the calendar, maybe for 3 weeks out, and maybe ish.
I'm probably let's find a time. I'm probably going to be out of town.
Yeah, are you in your move?
Not yet, in June.
Okay.
But we are visiting Argentina.
Oh, nice.
In 3 weeks.
So maybe so we'll pick a time maybe after I stop recording, but and I suppose maybe that we go into the Tudor show and tell mode. And so kind of given the learning objectives that you've heard, Tudor would be I suspect you have some things that you'd love to show that would find inspirational and dazzling and
can I ask you a question, envy. Tudor?
Yeah.
So here's a pet theory that I have of how one of the reasons they could build the system in so little code. That they rewrote it several times. They started over.
Oh, sure. I think that's necessary, but there are other things that get rewritten many times. If you're not specifically focusing on finding operators, if you're just focused on building implementations,
right?
But I don't believe you can possibly build a language without rewriting it. I don't think this is possible, or not by normal human brains. So we are throwing away about easily 2/3 of GT in terms of the code that we're writing, easily.
Wow. Is it getting smaller every time?
So yeah, that's one of the things. It doesn't get smaller because the surface area increases many times. So in terms of what we want to tackle, but it's
more dense.
It does get more dense, right? So that's because this is the interesting thing. If you're able to go up and like pick any place in the stack to add your solution, right? Then like you can just say, oh look, the only thing I need to just put it here, and then all of a sudden, we're gonna move, right? It's like that thing, when do you want to
leverage? The
switch
angle
when you're going to the moon, right? The angle and the space and so and so that's basically what happens. And sometimes we don't know the solution. So we're gonna try here because but this doesn't sound right, and then you go, and so we routinely throw away. So right now, for example, we just went through the process in a couple of days. We threw away one parallel framework, so a framework that does async, and put another one in. This was just in the core of the whole GT. And so we performed the refactoring within a couple of days, and we threw the other one away. And so we do this. So block was rewritten about 5 times.
Wow.
Over a period of, and now we're still finding places to refine it to. So especially when it comes to async, so asynchronous UI, there are still interesting things to find there.
And do you so Alan Kay has said this other thing, which I believe, which is that there's 2 theories that are both correct, but they're conflicting. One is, if you need to build something, like use existing tools and build it from those. and you'll move faster because you've got all this stuff you're building on top of. But then the other one is true, which is that if you've got enough of a time horizon, you're actually better off starting from scratch and building all the tools yourself.
Yeah.
And that time horizon is actually shorter than most people think, right? So,
Yes.
you know, he says like, well, if you've got 10 years to, you know, get somewhere, then you're actually better off starting from zero and building the language, building the compiler for the language, building everything, because you'll save time in the long run instead of fighting
Right.
all your tools. After 5
Yes.
years, you're just fighting your tools, and you've got all this legacy
Yes.
code.
Yeah, I think it's absolutely, and also like tied to it is the nature of funding, right? So
Right.
how do you find the funding? And he is mentioning this multiple times.
Right.
So how do you find the funding that does not ask you for the benefit before you have it, because you just don't know.
Right.
So in
You're
our
doing
case,
research.
right,
I don't know what I'm going to discover.
right, and so one of the things that, right, to think like if you go back to the 70s, right, I mean, even today, I mean, what we're doing, let's say it's maybe different than what happens somewhere else, but the jump is not that large. I mean, it's different, right? You feel uncomfortable, but it's still not that large of a jump. But at their time, like, you know, 30 years or 40, what is it now, 50 years ago, right? To imagine that it's possible to use the same energy that people are using to just put some form on the screen to now build a whole way of thinking.
Yeah.
That is just that's so I think that there's more than anything that is prescribable in there, which probably has to do with genius, but so, you know, there's a part of it too. But I still think that, you know, in terms of concreting, making something possible, making something like this possible, the nature of funding is super important.
Yeah.
So for example, in our work, we explicitly decouple anything, the way we get, we never promise anything that we haven't done yet first. And we, like, whenever we do, for example, consulting work, it might sound like, you know, science fiction for the people that we're working with, but there's nothing new in the territory when we promise something. There are also projects in which we do not promise. You know, how do you change a business? How do you make a development environment for a business? Not for a development team, but for a business, like where the CEO is integrated, where the developer is integrated. How do you do that? So this is a kind of a project which we don't know yet.
Yeah. Know the answer.
And for which you might we get funding, but there we don't have to promise, right? We just have to formulate the problem and get enough. But the ones that provide the funding, they have to be they have to think in a special way that today is difficult to find. So if you look at the time in, you know, 50 years ago with DARPA, for example, and then what happens at Xerox PARC, right? There was a significant fight to ensure that the people that are researching are not tied to promises. They do not necessarily formulate, that they don't have to formulate upfront what they think they're going to get. They might recognize it as they go along, or definitely not in the specifics, right? And it was kind of interesting, like at Xerox PARC, there were these stories where like it took because it was a business, right? It was a research attached to a business. So it took, like, after a while, they said, well, but we have to see something, right? And so I probably wasn't as smooth as it was in other places. So that the tension will always exist. And if you're able to find the nature of funding is I think plays a huge role in.
He says companies want to make billions, but not trillions. You know, that's his quote. You know, his pithy quote. Where, like, there's all these companies that if you took 1% of 1% of their profit, you could fund a Xerox PARC with that, a Xerox PARC style research lab, and just let them do whatever, just let them research. And then in 10 years, we'll have invented like a new computing paradigm. But they're kind of afraid of that. Like they'd rather invest that 1% of 1% in, I don't know, something that will pay off, with a certain guarantee.
For millions, not billions.
Yeah.
All the billions, not
So-
trillions. Love it.
Okay.
Can I propose I'm gonna hit the record. I propose that we move to adjourn soon. I'm gonna hit the stop recording and then we'll schedule next time. Does that work for you all?
Yeah.
And I want to get this on the recording. Tudor, thank you so much for affording us the opportunity to go on
Yeah.
this learning adventure. This has been like flipping awesome.
No,
Yeah.
thank you. Seriously, I'm not kidding. You're doing me a favor.
That's great. Mutually exothermic.